So this presentation is called GWT Can Do What? And I sort of chickened out. On the session agenda, it says, GWT can do what? Question mark, exclamation point, question mark, exclamation point. And I was feeling really ambitious a couple of months ago when we had to submit the title in abstract. But over the last couple of days, you know, I didn't want to set expectations too high. So I removed one of the question mark, exclamation point pairs. So maybe if you lower your expectations, if a demo screws up or something, it will not be a big deal. My name is Bruce Johnson. I run the Google engineering office in Atlanta. I'm the engineering manager of Google Web Toolkit. And I was the guy a few years ago who had this silly idea that, you know, hey, what if you actually just tried to compile Java into JavaScript? Well, it turns out that that does work pretty well. And since then, we've seen the GWT engineering team grow a lot, and we've seen the scope of what GWT does really, really increase as adoption of GWT has spiked, both inside and outside of Google. So a lot of you might know that GWT is an open source project, and if you want to get some idea of the rate of progress within GWT, I dare you to subscribe to the Subversion commit log emails and let those go to your inbox for a couple of days and see how long you can take it. But anyway, to emphasize the point, this is all open source development. You can watch the code reviews, design discussions happen yourself. Just go to the Google Web Toolkit contributors group on Google and please join right in. I would guess that a lot of you may already do that, and that's fantastic that you're here. So as we start to think about GWT 2.0, the thing that is mainly on my mind is, oh my gosh, this is a lot of stuff, and there used to be a time when I could kind of keep it all in my head, and I definitely cannot do that anymore. So really, the best I can hope to do is excite you about what's coming in GWT and persuade you to go to these other talks where you will learn about the real details from the engineers who are developing GWT and really big applications built with it. So a quick survey of the talks to come in the track. Measure in milliseconds. If you know anything about GWT, you know that we're sort of performance fanatics. This talk by Kelly Norton will explain why that matters from the end user's perspective and go through some of the sort of usability implications of the technologies we include in GWT to help you have higher performance applications. Ray Ryan is going to talk about architecture best practices and using as an example a from-scratch rewrite of Google's AdWords campaign management interface, the interface that advertisers use to control their ad campaigns on Google. Fairly important application for Google, and Ray was heavily involved in the architecture of that in the rewrite in GWT. Then Lex Spoon and I are doing a talk about some compiler details, especially code splitting, so that you will understand how to use code splitting well and how to basically read the tea leaves of the information that GWT compiler can provide to you as you optimize. The guys from Lombardi, Alex and Damon, are coming back to discuss lessons that they've learned in building a really phenomenal diagramming application in GWT. Highly recommend that talk. Another one from Ray Cromwell. Ray had a talk, GWT Extreme, last year that was an absolute hit, and I think he's going to pull that off again. This is about progressive enhancement using GWT Query, which is a jQuery-like library built with GWT. And he's going to do another talk that promises lots of cool demos that combines a bunch of different Google APIs together using GWT in ways that you might never have imagined. And then most of the GWT team, or maybe half of us, are here, and we'll be doing a fireside chat later, so we can talk shop then. We're excited about that. I want to emphasize especially this GWT Query talk because Ray has done such a good job with GWT Query, and the programming model is so powerful that we are going to roll that functionality into GWT itself, into the proper source control and distribution and everything. That may not be in 2.0, but it will be soon after. So you definitely want to come to that talk. It's sort of underselling itself based on the title, but he's going to explain this awesome new library and the work he's done to improve it. Okay. On to the overview. What's coming in 2.0? So first of all, as you saw if you went to the keynote, hopefully you did, you heard about the whole phone thing. Okay, you did. You saw Andrew Bowers talk about something called in-browser hosted mode, an improved version of hosted mode coming in GWT 2.0. If you've seen us talk about OOPHM or UFM, because we like pronouncing awkward-sounding acronyms on the GWT team, but we're probably going to have to abandon that by the time we actually ship it, because nobody really likes saying UFM. Some additional compiler enhancements. Code splitting, which was also mentioned in the keynote. ImageBundle on steroids, a new technology called Client Bundle. Improved layout and panels, which is always a source of angst, even using GWT today. We've got some really promising solutions in that area. And then a grab bag of not-to-miss features. So let's get started with hosted mode. All right. So first of all, hosted mode is good. I would not use GWT at all. I would not be interested in cross-compiling to JavaScript whatsoever if it weren't for hosted mode. Hosted mode is the key to productive development in GWT, and if you aren't using hosted mode, you're not really using GWT the way that we intended for it to work. It gives you the ability to debug in Java. It gives you the ability to make a change in your source code and hit refresh in the hosted browser so that the changes are picked up immediately. And it is important to mention that this is not a simulation of a browser. It actually is a browser. We just had to carefully wire it in to the JVM and bytecode layers so that it can do all the magic work. But you see the screenshot here. It isn't your browser, right? It's a special, SWT window that we had to construct. Which brings us to a problem. It's actually too special. We were only able to really make that happen for one browser per operating system. GWT does allow you to develop on Mac and Windows and Linux, but on each of those you can only use hosted mode for a particular browser on that development OS. In other words, you get Internet Explorer for hosted mode on Windows, you get Safari on Mac, and you get some ancient version of Mozilla that we... it's embarrassingly old. It's not at all like 3.5 era. It's also a particularly painful thing because the existing GWT panels don't solve layout perfectly. You still have to know a lot about CSS, and CSS is a very powerful technology. But as you saw, and everybody I think laughed about, the CSS is awesome mug in the keynote, you do spend a lot of time debugging CSS, like it or not. And it's really hard to do that in the hosted browser because it's our own browser Chrome, right? So we aren't able to allow extensions like Firebug and all these great things just aren't available at the same time as hosted mode debugging. So there's this other kind of related phenomenon, which is that it's hard to use browser plugins that expect to be running in a certain context. So Flash and applets and even Gears don't always work well in the hosted browser. So it can be hard to debug interactions with plugins. So what you find is that you compile a lot. And as soon as you start doing that, you realize that the compiler is not the fastest aspect of the GWT offerings. It's some have said slow. Just a random search for GWT on Twitter the night before last uncovered this little gem. That one pain point with GWT, it takes too long to compile. It's not an issue in hosted mode, which is good, but it slows you down while fixing browser issues. Since hosted mode really is a browser, what he means by fixing browser issues means fixing CSS and other types of issues that can't be accurately reflected in the hosted browser today. But the compiler isn't meant to be an alternative to hosted mode. You're supposed to use hosted mode to get your app like you like it, then compile it. So we had to make some pretty significant changes to hosted mode. The solution, it turns out, is to create a browser plugin and have your Java bytecode drive the browser plugin, a native code plugin into the browser. Then create such a plugin for every browser that we want to debug against and make that work across the network. And so I think it's best just if I show you. So now I'm going to do a little cross-window dragging here. Always difficult and dangerous. All right. So this is Showcase, which is sort of wow, this is actually going to be really hard, but I can do it. All right. Does that look okay? Okay. So we're going to do showcase. I still have the term UFM in there. The first thing you'll see is this. This is the highly unattractive, and because it's unfinished, UI. And it basically says that we are running a hosted mode session as a server. So I'll hide that window, okay? Now, hosted mode is sitting there waiting for us. And I can enter the URL from, oh yeah, you can't see this. Actually, hang on. This is driving me insane. So I hope this is not going to like totally demolish what we've got going here with the video, but I've got to do it. Yeah. How's that? Okay. Now, okay, sanity regained. All right, so now I navigate from a regular Safari instance to the showcase URL. It's what I would have normally done in the hosted browser, except this is regular old Safari, which means I get all the tools that I would expect to have in Safari and any other plugins that run in Safari and so on. So now hosted mode is no longer trapped inside the hosted mode browser. So that's not the excitingest part. This isn't the excitingest part either, the next thing I'm going to show you, but it is exciting-er. All right. So we also have this working in Firefox. So I'll visit the same URL. But there's a couple of interesting things to point out here. You're seeing both instances run against the same hosted mode session, and that works fine. It's like a server on top of your Java code base. And so if we look back at the debugger here, we just see a thread here and a thread here for each of the browsers that are connected. Okay, and that's pretty cool. And then you want to do things like debug CSS, right? So this is one of the key use cases for out-of-process hosted mode, for this new plugin-based hosted mode, to be able to do things like use Firebug at the same time. So I'm able to make real-time changes, and especially when you're tweaking CSS, it really helps to be able to have the full power of Firebug, even while you're debugging your Java code at the same time. So hopefully this is going to go a long way towards making people able to use hosted mode for the trickiest situations. All right. Now, that also, by the way, was not the excitingest part. What to me is the excitingest part is the fact that if you're developing cross-browser, you have to remember not every browser runs on every operating system, obviously. Internet Explorer, not to name names, doesn't run on Mac, for example. So, but it has large market share, so I need to support it, obviously. I'd like to be able to debug with hosted mode against Internet Explorer, but I want to run Eclipse on my Mac, of course. So that works, too. I have a VMware session here. And it's actually using cross-process communication across the network to hit the server that is running hosted mode. And now you can see all three sessions are running, and they each have their own log at the same time. Cool. But wait, there's more. That's what you're supposed to say during the demos. You're supposed to say, but wait, there's more. Yeah, we'll do questions at the end because there's a microphone, and for the video's purposes, we have to have people do that. So it just wouldn't be a hosted mode demo unless we showed hitting a breakpoint, right? So I clicked on the hyperlink in Internet Explorer in a VMware session, triggered a breakpoint back on my Mac in Eclipse here. And I can step through line at a time. I can do everything that I'm used to doing in hosted mode, including things like getting the inner HTML associated with widgets and so on. So this is actually going back to Internet Explorer and extracting the DOM structure as HTML and sending it back so that we can stay in our debugger and not have to constantly flip back and forth when we don't want to. Also, we think pretty time-saving. And then another thing that would not be a hosted mode demo without showing is the ability to quickly refresh. So, okay, I'm going to change this subtitle right here, Showcase of Features. Edited live at I/O. And then refresh in the browser. And you see the edit took place. Okay. That is out of process hosted mode. Where were we? Okay, so now we talk a little bit more about the compiler. The best thing to do is not compile, if I haven't made that clear, okay? Caveats and mumble. Right? So this is times on my MacBook Pro, which is a 2-core computer. Compiling a showcase sample in version 1.6 of GWT took 144 seconds. Okay. But we keep adding features to the compiler, optimizations, code splitting, and all that. That takes time. So as much as I'd like to show you the next bar being smaller, it's actually larger right now. There's still some tweaks. We'll spend a little time with JProfiler, and we can probably get the compiler a bit faster still. But the reason it takes so long is GWT does an optimized version of the compiled script for different browsers and different locales and different contexts. That's one of the key strengths in why GWT does actually produce really fast JavaScript code. So there's sort of a limit to how fast the compiler can be in theory. It's why we invest so heavily in hosted mode. But there's still some things we can do and have done. In GWT 1.6, which is available as a download right now, there is a -local workers flag, and you can specify the number of Java processes sub-processes you'd like to start to run the compiler to compile those permutations in parallel. So if you find the sweet spot relative to your amount of RAM and relative to your number of cores, you can actually speed things up a lot. As you see here, with local workers equal 2, I can compile 25 permutations in about 2 minutes. That's still not great. So in 2.0, we're adding a -draft compile flag. What this says is, look, I just really want to compile fast. I don't mind if the output isn't as good. So the compiler does fewer optimizations, and the resulting script runs the same, but isn't as optimized, and you wouldn't want to ship it into production. But it does speed things up, as you can see. So now we're about a third the time as we were without using these flags. There's a trick we've said from the beginning that you should do if you're doing a bunch of desk compiles, which is to restrict the number of permutations in your GWT module. People call this a single perm compile and things like that. You can using an XML element called set property, you can restrict certain values. You could say only compile for user agent IE6, for example. In GWT 1.6, we added the ability to set that as a subset, a multiple value. So it's not just exactly one permutation. You can actually kind of craft your own number of permutations. I could say compile for Safari and IE6 and English and French. Even if the total number of permutations are really large, you can kind of pick and choose the subset that you're actually focusing on at the time. And if I do that, you can see you can save a lot of time. Now we're at about 1/9. And did I mention that hosted mode is a lot faster than the compiler. And plus, you can debug. It's a lot of good things about hosted mode. But we also say refresh rather than restart hosted mode. So you can leave the hosted mode browser running. Occasionally, you'll get an error message that's from the JVM that says something about not able to hot swap in code. You can completely ignore that. You can say, don't talk to me about this anymore, because the hosted mode infrastructure automatically recompiles things into RAM for you. So it will always work, and you can safely ignore those. In other words, do run hosted mode for long periods of time, and do hit refresh, and you get this kind of turnaround time. So basically, instead of waiting 186 seconds, you can wait 2 seconds to see the results of your change, and you can still do all the things you would have needed to compile for. You can now do that using out-of-process hosted mode, the plugin-based hosted mode. Just to underscore the point. Plus, I just discovered Keynote animations, so I'm definitely going to be over the top with that. All right, let's talk about code splitting. What happens is your scripts become really big. Especially if you haven't done enough JavaScript development beforehand to be incredibly afraid of browsers. You might not approach a GWT project. Hey, I did turn that off, I swear. You might not approach a GWT project with sufficient trepidation. You might feel a little too confident. You might say, hey, wow, this is great. I can write Java code, and it just magically turns into super optimized JavaScript. Well, we do optimize, but it's still proportional to the amount of Java code that you write. So don't be complacent. You want to think about the size of your script and performance from the very beginning. For one reason, you have to download that script when the user visits the site. So if you get 1 megabyte of JavaScript, that is just going to take a while, especially for users with slower connections. It also can trigger some pathological behavior in certain browsers who shall remain nameless. The parsers were written at a time when nobody expected to be parsing a megabyte of JavaScript. So some of the internal data structures that they use have worse than linear time with respect to the number of lines of JavaScript code. There is one thing we can do and have done in GWT 2.0, which is to break really long script blocks into just multiple script blocks. Believe it or not, just inserting extra script tags does something to reset the internal compiler, the JavaScript parser state, so that it actually sort of does avoid that script time, the pathological behavior. So we help you out somewhat, but still, in general, the UI is locked up, and that's not good. That's the last thing you want to do is hang the browser. Remember from the keynote, I will not hose the browser with JavaScript. We help you write a lot of JavaScript, but we still don't want you to hose the browser. So, and then also remember that a lot of times with GWT, you run code to produce DOM structures that then render as the UI. If you have to parse a lot of script at startup, that adds latency to the beginning before your code can start running to build the UI that then has to get rendered. Long story short, you don't want to wait too long to parse a really large bit of JavaScript. So, seems like a problem for GWT to solve. Did I mention I discovered the animations in Keynote? So, we've got the ability to drop split points. The API is called gwt.runAsync. And all you do is pass a callback into runAsync. Okay, so that's an example of the split point. If the code fragment successfully downloads, the onSuccess callback will be called. But it's possible that the code fragment might fail to download if there was a network hiccup or a problem like that, in which case you have that. I promise there's no more annoying animations after that. I pretty much milked that joke. All right, so does that kind of make sense? The idea is the compiler can see what's within the onSuccess method there. And it does something that Lex deemed dead for now code elimination. And so it starts with that as the beginning of a set of dependencies. So this is sort of it creates a split point in the dependency graph that the compiler can analyze and to make splitting decisions. So let's see what happens when we split showcase up. The original showcase, the unsplit version, requires 108K gzipped, which is like, I think, 388K ungzipped. But you should always serve script gzipped. Anyway, 108K, and then the split version can actually get the showcase UI up and interactive with about half that amount of script, just by carefully dropping some split points in. Let's look at the way we did that in showcase. That's what happens if you just stop the Java side of hosted mode. All right. It's also, I guess, worth mentioning that code splitting, we designed it to not require any particular server-side support. So you can actually even run split code directly from the file system, which is what I'm doing here. Because the last thing you want is to be forced to use some complicated servlet configuration and that sort of thing. So we did not do that. So if you'll just watch over here on the screen to the right, you can watch as new bits of code are being fetched. We created a split point everywhere that there's a primary hyperlink here in the tree. So you can see it. There's really two things. You can see that the code loads, which is cool. But even cooler is the fact that you can't tell that the code is loading. Just watch the UI for a second. I mean, it pops in essentially immediately. Because we've amortized the cost of loading that code. You know, we split what was 108K across a bunch of different actions. And users do expect sometimes there to be a slight delay when they do something. If you can make your code split well, then the delay will be negligible, and so it's good all around. Okay, we saw that. So there's a few things to know about runAsync. So it is intentionally developer guided. As these sorts of techniques are starting to become popular, there's different philosophies about how code splitting should work. We say that it should not be an automatic process. We say that the developer has to know what sort of functionality might be appropriate time to split out some code, where there might be a network delay. For example, clicking on the settings page is a perfect thing. You rarely click on settings like once out of every 10 times you use an application. That's a perfect time to be willing to suffer a delay. So you would put the UI for showing settings page behind a split point. Let's think about a system that didn't work this way, that just sort of magically figured out how to split your code. You don't know what's going to get split out when. I mean, maybe there's some sort of magical machine learning algorithm or something that could do this for you, but that may be a ways out. It's actually intentionally asynchronous because it's really important not to lock up the browser UI while the code is being fetched. And importantly, the user might click on the settings page or some other expensive piece of functionality, but then immediately change his or her mind and want to go do something else. So we can't have a situation where you call a method that requires code to be fetched that literally hangs execution of the JavaScript thread, because that thread is the same thread that allows you to interact with the browser. So it is asynchronous. It's not the easiest programming model in the world, but it does provide the best user experience, which is ultimately what we're after. It also forces you to think about failure paths. Imagine a situation where there weren't a callback and there weren't a method called onFailure that you had to fill in. You might never think about it. If just some random exception got thrown in the case of failure, you would never know where you should and shouldn't try to catch this fragment failed to load exception and so on. So either you don't ever catch it, in which case you don't have good error handling, or you get paranoid and wrap every single method in a try-catch because anything could potentially fail, and that's bad for the reason that it would increase code size and slow things down. So we've tried to be really careful in how we design it, and as you get to know the way that code splitting works and use it in your own applications, we hope that you'll be mindful of the reasons it was designed the way that it is. Also important to note that the split point doesn't actually mean it will delay at that point. It's not necessarily true that you will fetch exactly at the moment the split point is reached in the control flow. We can do things like prefetch. That would be possible. You can do that by creating a custom linker. It would also be, the fragments are perfectly cacheable. They have strong name URLs so that you can provide it never expires headers so they can be cached locally in the browser. So it doesn't necessarily mean slow. It also doesn't necessarily mean split. The compiler can choose to ignore a split point. It tries to do a good job of finding a balance of minimizing the total number of fragments, making them cacheable, honoring all the different static dependencies in your code, and which is all that stuff I just said. And to understand more about the specifics here, I invite you to come to the Story of Your Compile Reading Tea Leaves talk that Lex and I are doing tomorrow, where we go into this in a lot more detail. I guess one last point is, we are really excited about this feature because it is so very hard to do this any other way. We've seen teams try to split code manually across JavaScript files and think about when they should load which module and create these elaborate diagrams and so on. And they might get it working this week, but then a month from now, other people come along and they write code not understanding the dependency order, and they call a function that wouldn't yet have been loaded, and you have an explosion. Okay, now client bundle. Let's revisit ImageBundle, which is sort of a new direction that we went in 1.4 with GWT. And it leverages the fact that GWT can do compile time code generation and compile time resource generation. I'll explain how that works a little bit. So let's say the easiest thing for you to do in your email application is to organize your files as separate JPEGs or something, and they're scattered in a way that makes sense to you or to your designers. Okay, that's great, but that's not the same as what's good for the end user. So there's this divide between how you want to organize your code in development and how you'd like it to be served for a high-performance user experience, in production. So when we add up the sizes, and I actually did this, add up the sizes of these individual images, it comes out to something like 20K. But what GWT lets you do is construct an image bundle, which is a simple code generation-based API that can, at compile time, take those images, put them together in a single image strip, and provide you hooks so that you can refer to them as viewports, basically sprites within the one image. So that means some goodness happens. Some of the goodness is you remove all the redundant image file header information. There's just boilerplate in every individual image file. By combining these into one, you actually can remove that redundancy. And so literally, the combined image is actually smaller than the individual images in total. In terms of HTTP requests, that's really huge. It means one request that is instead of 11, which is really important because some browsers still have a 2 connection limit. In other words, if I'm going to fetch 11 different images, the 2 outgoing connections are completely saturated. And so if I've got an RPC that I need to do, it's waiting in line behind 11 images being requested at the same time. So your user's twiddling their thumbs and maybe thinking about going to check out, Twitter or Facebook or something. There's also a really nice caching story because we are able to generate the bundled image such that its name is an MD5 hash of its very pixel content. So you can provide, you can set never expires headers on that resource. The browser can cache it locally, and if the code ever changes, like if you change one of the images and redeploy, then your script would have a reference to a different MD5 named image. So in other words, you can cache permanently on the client, but you're never at risk that that client code will refer to the wrong image. It's a little complicated, but really the point is you don't have to think about it. You just get the benefit. Okay, so with that as background, let's talk about what Client Bundle is. Client Bundle generalizes this concept to arbitrary resource types. Let's walk through one. So I'm going to create an interface called MyBundle that extends Client Bundle. I'll create an instance using gwd.create, which is the magic call that allows this code generation to happen. And then I can do, this is very much in line with ImageBundle, I can refer to smiley.gif. And when I call this method smiley image in code, it'll return me a resource that represents a sprite within the bundled image. If I can have another image, and I can be sure that this will get bundled together nicely. But for the first time with Client Bundle, you can do other things. You can bundle in, for example, text resources. So let's say rather than configuring your application in Java code, you like to keep the config in a separate XML file as part of your project structure. That doesn't mean you actually want to serve an XML file to the client in order to make this go, right? But it would be wasteful. So I can instead create a method like this called appconfig, and it will automatically compile in the text of that XML into my JavaScript. I can do the same thing with, if it's, for example, if it's a larger text resource, I can specify the external text resource type as the return value. And that has an API that allows there to be a level of indirection. It's an asynchronous request. So that depending on other settings, it can either be bundled or it can be fetched. In the case where it's fetched, if it's a large file that's rarely used, for example, its contents are MD5 encoded. I mean, its name is MD5 encoded, so you can use the same perfect caching trick for large things. I used word list as an example because you could imagine a spell checker with a large word list that you wanted to download might be something you would want to cache. You can even do crazy things like PDFs. If there was some reason you needed a PDF or, I don't know, WAV data or MP3 data, you can actually do that as well. And this data resource type, the return type here, it has a method called getURL. And that URL, depending on the browser, may be one of a couple different things. On a browser, say an older browser, it might be an actual URL to your server. But on a newer browser that supports data URLs, it actually might literally be a data URL containing the base 64 encoded bits of that thing. In other words, I can bundle PDF data, just as an example, directly into my compiled JavaScript. So you have a lot of control over how your resources get deployed and downloaded. One of the coolest things, which I'll come back to in a second, is CSS processing. You can do you can bundle CSS files directly into your JavaScript code instead of making separate HTTP requests. But you can also do a lot of fancy things with the CSS as you bundle it, which I'll come back to. But let's just go really quickly through the text resource example. So again, I'm going to have my appconfig XML file. I want to make it available to my application code by calling this method appconfig. Just declare it like that. Let's say that the XML file itself looks like this. It's got settings that I want to compile into my app. So animation speed, maybe a failover strategy. All right, this just needs to be available on your class path at compile time. So this is some code where I'm actually going to use this bundle. I'll grab the instance in the bundle variable there. I'll call the appconfig method, which returns the text resource. It has a getText method that gives me the XML that was attached to my compiled script. And then I can pass that into the GWT XML library and set up my application. So there's a few really cool points here. Obviously, it's great to know that this is going to succeed. It's not going to require a round trip. It's compiled into your script. You can use the file format you want, in this case XML. You might use JSON for config these days. And then the most exciting part is CSS resource. We actually have a CSS parser, and because we're going through all the trouble of parsing it, we figure we might as well throw in some extra features to help you deal with CSS while you're at it. Things like defining constants in CSS is something that a lot of people have wanted for a long time, and we can give that to you today with Client Bundle. I mean, maybe if you're extremely ambitious, you'd use some sort of crazy, sed script or Perl script in your own CSS to achieve the same effect. But it's nice to know that you're getting a real parser that can actually cross-check that if you refer to a value, for example, scary color for an error message, right? Scary color does actually, in fact, map onto something that was defined, right? If I misspelled it, that would be a compile time error. That's another really nice benefit. Because CSS is still awesome right now, and it's more awesome than reliable. For now, obviously it's going to improve, but for now. There may be cases where you need to do different things. So right now, the rounded border radius is an example of where you might want to do that. So you can actually use conditional constructs to define CSS rules differently in different cases. I think this one's pretty self-evident. But the values there are deferred binding properties. And then really there's way more to say about what CSS resource can do. It obviously can minify, so remove white space and comments from your CSS, which really adds up. It can even obfuscate the names of the CSS classes. If you're careful about how the discipline you use to refer to CSS names within your Java source code, the CSS generator can actually obfuscate those names. Your code never knows the difference. But what's actually downloaded is smaller, runs faster, and so on. There's additional fancy spriting with tiling, and you can even, from a CSS rule, call back into your Java code to get a value that gets concatenated into the CSS that then gets injected. So lots of fancy stuff. If you research it, just do a Google search and you'll see lots of examples. There's a CSS resource cookbook on Google Code. Okay, so layout's another big area. First thing to know about layout is don't do it. In other words, don't do it yourself. If you find yourself writing code in response to the resize event, the window resize event, you're already losing, because it's such a worse user experience when you have to run code to adjust the way things are laid out than to have the browser do it itself in native code. So if you're doing anything like measuring things, like how long is this div exactly? You're asking for offset widths and things like that. You're almost guaranteed to be on a path to bad performance. Instead, like I said, you want to use implicit layout, have the browser do it. So for probably borderline excruciating details, no, extremely interesting details, talk to Kelly Norton and, talk to him, but go to his talk, Measuring Milliseconds, which is, I think, the one right after this. And you will really find it interesting. Okay. So, but the downside is we use tables and a lot of other things that are lamented by us and everybody else in order to try to simulate the right kind of constraint-based layout. With 100% works really well and consistently, generally. But inevitably, people occasionally want application-style layout, where it takes the entire browser window, and if you resize the browser window, everything resizes along with it. So you want to use height 100% naturally. It's the first thing people do, right? But that never works. It just doesn't. And it fails wonderfully and differently in different browsers. I say fails. It fails if you consider it looking completely awful and not working well. It doesn't actually crash your computer. It doesn't format your hard drive, but it makes your app completely useless. So that's a pretty big fail. But, let me show you what I mean. So this isn't so much a failure. This is more just how things can not look great. So in the mail sample that we ship, we're actually doing this right now because we didn't have a better way of doing it in the past. You guys have, I'm sure, seen this. But watch as I drag this around. See that lagginess? That's horrible. And I'm not blaming Firefox for this. This is just sort of the way it has to happen, because the window on resize event has to run some JavaScript code and so on. But back, this is Firefox 3. At this time, the layout engine's still somewhat slow. So you can't literally run that event for every single time that the browser is resized by a single pixel, right? So it has to have this artificial delay, and consequently you get this yuckiness. All right. Not to mention, getting the code to work well at all is hard, and you have to kind of already be an Ajax expert, which is kind of the reason GWT was invented, is so that you don't have to be, right? All right. Now I'll show you what it looks like. Actually, first I'll tell you a couple more things. In standards mode, we do have some additional reliable behavior with CSS. And you can actually get constraint-based layout that does what you want, and you don't have to hook resize. So we're going to have an updated set of panels in 2.0, and I'll show you the new and improved dock panel. This is the well-known on module load. So this probably isn't the final name of this panel. This is really still basically prototype code. But let's say you instantiate it. You specify a unit, but that unit can be anything. And then you specify sizes for things and various types of constraints. It looks pretty familiar if you've used dock panel before. We did also add the ability to add splitters just directly into the dock panel. So for sophisticated layouts, it can work well. And a couple of other things I want to set. So this is pretty familiar looking UI code. This is the code you've always been wanting to write. But let's look at how this actually looks. So first of all, it's fast. Because we're using CSS for everything, you can see that I can't move the window fast enough to outpace what's happening here. It keeps up with me. Right? Now, it's interesting to note that no JavaScript code is running as I'm resizing here. This is all based on CSS constraints and the way that that panel happens to use them and construct them. As I mentioned, you got splitters here that you can use. You've got internal scrolling. We also did a little example of a stack panel that uses the same sort of technique. And getting the stack panel to resize properly when nested in another thing, I don't know if you've ever tried this, it can be a real hassle. It just works with the new approach. So you specify various different kinds of constraints. In fact, it was recognized that this is pretty much the same set of constraints that you get when designing Cocoa apps on OS X. And then we even were able to, as you specify that you want to change the size of something from one size to another, we can make that animate. So, for example, if I double-click on this, I get an automatically resize, which is nice. So what I'm really showing there is an approach to layout. So that particular panel isn't the thing to be excited about necessarily. It's that we're going to be able to take that same approach to recreate all the other panels, and they will tend to just work exactly like you had hoped they would. Okay, a few last things that I just can't not mention. We've added some compiler flags. There's one called disable class metadata. The -X means you better know what you're doing before you do this. But there's certain constructs in Java, calling object.getClass or class.getName forces us to compile in class literals, and those class literals have names that are strings that show up, and for a couple of reasons that's not great. But if you really don't actually care what class.getName returns, you don't care that it says, com.example.mywonderfulapp, you just want it to return a stable string, then we can do this. Here's the showcase metadata. I snipped out just the part where there are class literals with their names and everything. That's at 1-point font. And I flip this switch on, and we get between 5 and 10% script reduction, and here's what it looks like after. It's not huge, but on a big application, this can really add up. But again, it's less code to download, less code to parse. It actually runs faster because you're not constructing as much when you're creating class literals. And it's a little bit more of an obscurity benefit. When people are looking at your source, they don't see all the type names and so on. In a similar vein, we've got DisableCastChecking, because nobody, I hope nobody, writes code like this. So somebody wrote this silly method that you pass in an animal, and then you try to make it quack, but you don't know what kind of animal it is, so you cast it to a quacker, and then you call quack on it, but you're being defensive, so you catch the class cast exception, right? Because people could pass in non-quackable objects, obviously. But people are laughing because nobody writes this code, right? But yet we still, technically have to generate code that checks this anyway at runtime. And that's unfortunate because it means there's lots of tables that we have to produce to say this can be cast to that and so on. And we have to emit the code to do the dynamic cast checking, which actually slows things down a lot. You turn this flag on, and this is what you get in the compiled output. So in other words, it trusts you. It basically says, I'm never going to throw a class cast exception. you better not depend on that being thrown. But assuming you didn't write stupid code, in my humble opinion, then you're going to see real speed-ups. So 1% size reduction and 10% speed improvement in performance-sensitive code, which 10% for merely flipping on a flag is not bad. That was actually in AdWords. We worked with them to try out this flag, and indeed 10% faster with a simple rebuild. Okay, a couple more tidbits, and then we'll do some Q&A. So GWT RPC is polymorphic. And so one of the things that you find if you use a lot of RPC is that the RPC code generator tries to infer what types might be serializable. So it'll kind of walks the type hierarchy. And if you send an animal, it will try to find all the different kind of animals that there are. Whether or not you actually do want to send a rhinoceros from the server to the client, if you have an RPC method that returns type animal, it has to be prepared to receive a rhinoceros over the wire. So there are cases where you can look at your code output and say, I definitely will not be sending rhinoceroses from the server to the client. Rhinoceri? Anyway. And so you can just tell the RPC code generator, here's a list of types that I am definitely not wanting you to serialize. And it turns out that this is really beneficial. So you can just go through and easily just chop out a whole bunch of code and make your script smaller. So it's really pragmatic and easy to use. Another one that comes up a lot with RPC is the fact that people sometimes want to have the functionality of Request Builder, but with the simplicity of RPC. And so we've introduced a way to actually combine the two. So you can take an RPC interface and specify the RPC Request Builder instance that you'd like to use. So that allows you to do things like set custom request headers in HTTP, set timeouts, all sorts of things. You do that to the RPC interface itself, and every individual RPC method call within that interface will use exactly that same request builder process. If you've used RPC for anything non-trivial, that will make sense. And if you haven't, it probably didn't make sense, but that's okay. There's even client-side stack traces on some browsers now. So at least on Firefox, this is reliable. And we do it without actually generating any additional code. There's a way to do it, obviously, by generating code into the compiled script. The compiler could do all the bookkeeping and so on. But we think that might be a little too costly in terms of size and speed. But actually, the browser is able to give you stack backtrace on exceptions in JavaScript. It's tricky because the names are obfuscated in production, so the stack traces look like a bunch of obfuscated names. But the compiler now also produces symbol maps that you can have on the server, so that if you catch an exception on the client, generate a stack trace, send that up in obfuscated form to your server, then you can combine that with the symbol maps, and then you can see the full, the actual names of the methods that were involved in the stack trace on the client. So it's pretty cool when you actually see it. And that is increasingly working. Last thing that came up is we introduced last year at I.O. Something called JavaScript overlay types, which lets you model JavaScript objects directly into the Java type system. So I can create a Java class that I superimpose directly in a JavaScript object. And it can be faster, especially for JSON. It's a really efficient way to interact with JSON objects. But the problem is people wanted to use it for JSON. So they want to send JSON structures from the server to the client. But the server can't actually use the JSNI, the JavaScript code on the server. And overlay types didn't support interfaces. So in other words, for the server to use that same class is impossible. So now we've introduced the ability for overlay types to implement interfaces so that on the server side, you can implement some JSON-oriented interface, let's say person, that's basically a bean-like interface. Get first name, get last name. You can implement it on the server using regular Java bytecode. You can implement it on the client using an overlay type. And so you can actually share a whole bunch of code in terms of that interface between the client and the server. Again, if you've never done this, that probably doesn't make a whole lot of sense, but if you have, hopefully you will see the benefit, and we can talk a lot more about that. We have the office hours we're going to have scheduled to talk about the compiler and lots of other good stuff, and hopefully we'll just bump into each other in the hallways. And that is pretty much it. I think let's go ahead and we have about 5 minutes left. If we can do some quick Q&A, but please do come to the microphones since the audio needs to go into YouTube. Thank you. Yes.
Hey, sorry, it's loud. The code splitting stuff looks really cool. I'm wondering what it does for localized resources, CSS, if there's anything.
Oh yeah, that's a great question. That was a huge point I failed to make. When you combine client bundle and code splitting, it's really awesome because client bundle, literally can like bundle in the variables and so on. In other words, you have fields that get generated by the client bundle that contain things like CSS values, literals, and even the PDF example, right? That would become a field at compile time. And then code splitting can actually do the static analysis to say this huge chunk of CSS isn't actually reachable from the startup fragment. And so it actually can push resources automatically out into different fragments. So they're loaded only along with the code that needs them. So thank you for that question. I'm glad I messed that one up. Yes, whomever.
Okay, so obviously as soon as we can start debugging in any browser, we're going to upgrade right away. That's pretty awesome. But I noticed that console window that has an instance for each browser. I mean, can we still run in hosted mode with our own server?
Yes.
Okay.
Yes,
cool. Awesome.
Definitely, yes.
Good improvement.
Yes, you can.
So the question is, do you have any plans to have a different way of organizing the layout instead of writing code? I had a quick look at Android, and they have this XML declaration of the positioning of the widgets. Do you have some plan of putting some work into it so that we don't have to build the panels in Java and all?
Yes, it's a little bit further out in the pipeline, but you might have seen a design doc on our wiki for something called declarative UI. It's now called UI Binder. But it's an XML-based declarative way of specifying all the same stuff that you would do in code.
And you have no timeline on when this would be able to play around?
I mean, I can't be trusted because I'm always the guy saying, yeah, let's add it to 2.0. But then, the product managers and so on, they don't like that. So I have to underpromise, maybe, hopefully over-deliver. But I can't really say that it'll be ready for 2.0. But not too much longer. It's really in use at Google. So in fact, you'll see, if you go to a lot of Quit talks, you'll see examples of apps that use that heavily already within Google. So, yes.
Hi, the code splitting stuff looks great. We've been really hurting for the lack of it. The question I have is, you said that you build a dependence graph, and so the thing that naturally pops into my mind is, how do I either avoid or break those dependencies? What kind of things do I have to worry about?
Okay, so that is exactly what the story of your compile is all about. Mm-hmm. So the story of your compile, reading tea leaves for an optimized future talk, goes into that. It takes you step by step through that scenario and how to solve it.
Great, thanks.
Yeah.
Hi. Does the CSS compiler warn you if you write CSS that doesn't actually get used, or the other way around, reference CSS that you forgot to put in?
Yes, that's another thing I forgot to mention. If you organize your CSS right, it's like dead CSS elimination.
Nice.
Right.
Hi. What's the timeline for the 2.0 general release?
It's another one of those things where I have made bold proclamations in the past and gotten burned because I was too optimistic. I can't say, but it will be. We would like to start thinking about trying to get it out in Q3.
Okay, thanks.
So it's not like a year out. So to be clear, all this stuff is actually in the trunk right now. You could, if you're sufficiently brave, you can check this out as a version and run it yourself. In fact, Google projects using GWT do run off the tip of trunk. So again, the apps that you'll see today and tomorrow, I think you'll find very compelling applications. These are all built with the bleeding edge. Yes?
When you were talking about code splitting, you mentioned the example of, say, a settings page, and it struck me that one of the first things that setting page might want to do once the code is down is go to the server and get all my settings. Is there any way to package data with the code in a code split to avoid that extra round trip?
That's a good question. It's probably one we'll have a little more time to talk about that if you come to the reading the tea leaves talk, or maybe in the hallway. But not out of the question. You have to think about cacheability. If you mix code and code that doesn't change over time with data that does.
Yeah, but I mean, the first time you get that code, you might as well throw something.
Yeah, potentially so. There might be some tricks like that we can pull. But let's talk more.
Thanks.
We are out of time now, guys. I'm sorry. If there are still remaining questions, we'll catch you guys out in the hallway. Thanks. And stick around for Kelly's talk.